Please welcome Alejandra, Jan, and Manu, and get your laptops ready for State in Compose.
Hola. Perfect. Okay. Hi. Morning, everyone. How are you? I'm Alejandra, Stamato, and together today with Ian and Manu and a bunch of several folks, we're going to be here to talk to you about state in Jetpack Compose. And also we're going to go through, well, actually, let's see what we're going to be doing. So I'm going to talk a little bit about states and events. Some concepts you might already be familiar with, state hoisting and the role of the view models in a Compose app. And then we're going to jump into the workshop itself. If you cannot hear me because I do this a lot, I apologize. I wish I had a microphone. Great. Awesome. So I'm here to talk about state. What is state? So state is any value in an app that can change over time. And this can be very, very small, like a variable representing a counter. Or it could be more complex than that, a complex class, or like the list of your message, all of your latest messages in an app. And how do we modify that state with events? With events. Cool, easy. So in every Android application, there is a UI event loop that looks like this. There is an event happening, and that produces the state to be updated, and then that's what's going to drive the UI change, and then from the UI you can generate other events. Most typically those will be user events, but those events can come also from the apps, the devices, sensors reading a new value, etc. So anything that can change that would trigger an event, and that would generate your state to be updated. Whoa. So some key definitions, we call composition to a description of the UI built by Compose when it executes your composable. So you will run all of your composable, and that would generate and emit UI to the screen. In a similar fashion, recomposition is the process in which all of your composables are rerun when and if that data changes. So the UI is updated. In Compose, there is a state tracking system in which if you use Compose's API to represent your state, this will schedule recompositions automatically for you without you having to actually call the UI to update for any composables that read that state which you use the API to host it with. We're going to see how that looks like in a second. So after those three definitions, this is what a composition will look like then. Like this is the life cycle of a composable function in which your composable enters the composition. It can recompose 0 or more times because the state that it's reading changes. And then it just leaves the composition because your UI has been replaced with another composable, and then that's it. So yeah, this is the life cycle. As your activity has a life cycle, our composable functions also have a life cycle. Great. So when we said state tracking system, well, API is what we were referring to, of course. In Compose, you should represent your state using mutable state, and you define it like this, mutableStateOf. This is a class that wraps your state in a class, and then you can access it through the internal value. And then you can access it like this to modify, in this case, a mutableStateOf int, so you can just access the value on, for example, it's a counter, so just like add 1 to it, and then it will look like this, and then that's it. With that. We talked about the life cycle of a composable, so when a recompositor is generated, you really wouldn't want to lose the state that you had. So what you typically do is use mutable state with remember together in the context of a composable function. So with this syntax here, you're using the composable remember to remember your state defined by mutableStateOf. So with the composable function recomposes, you don't lose the state that you modified. And you can also access it in the same way with value. But this syntax is a little bit cumbersome, so maybe we can do something better than that. And this is replacing your val by a var and using Kotlin's delegated properties syntax. So instead of defining it with equals, you define it with by, and then you can delegate in the setter and the getter to the composable methods, and now you can access it as if it were your normal integer. So it's like very transparent that it's mutable state, snapshot state, or what is it. So it's more comfortable depending on your use case. You might want to use this syntax. It's just syntactic sugaring. By, there you are. Yeah. Another famous character is rememberSaveable. So we were talking about how remember helps you survive changes in your recomposition. Use rememberSaveable when you need that state to be saved across process def, like the activity dies, or across configuration changes, like rotating your device, changing your theme, changing your language in your device, etc. For that, you would use rememberSaveable. And then, almost finally, if you have a list of data as opposed to a normal int or another class, and you want to observe changes that happen to the list when you remove and add components, so the structure, like the structure of the list changes, what you want to do is declare that as mutableStateOf. And then with this extension function there, you're already tracking what happens when the list changes structurally, and then your UI will be notified, and that's how you can remove items visually. And you would use mutableStateListOf. Great. So a couple last definitions. State hoisting. Why do we need state hoisting? Because composable internal state tend to be less reusable and harder to test. So what we want to do is separate this into two composables, stateless and a stateful composable function. A stateful composable owns the state, and a stateless composable doesn't hold any state, is not the owner of any state, which means that can be used with different instances of state. This pattern of separating that and moving the state to composable's color to make a composable stateless is what we call state hoisting. And that was too quick, right? There. And usually the strategy that we take to state hoist is we take the state that you want to extract and we replace it with two parameters. The value itself, the state, and then what happens with the value changes, typically in a lambda function that you put in your composable functions firm, and then that event can flow up, and whoever is implementing that behavior can be notified. You will be more typically another layer of your app, could be a view model, could be whatever is the business logic is handled. Speaking of view models, Manu's favorite class, so it provides the UI state and access to the business logic. And the great thing about the view model is that it lives longer than the composition. So you would get this rememberSaveable behavior for free, as in state that is hoisted to the view model will survive configuration changes out of the box. You can access your view model from any composable function using view model method like this. If your view model doesn't have any, it doesn't receive any parameters, only thing that you have to make sure is use the library lifecycle view model compose, and then you're ready to go. But even though you can technically do this of defining, of accessing your view model anywhere, maybe you shouldn't really. Where you should be accessing your view model is a screen level composable, at least that's our recommendation. Access the view model in state level, screen level composable, and then delegate the state and the behavior to the other layers of your composables. And this is because if not, you're going to be coupling your lower layer composables to your view model. Probably you don't want to do that. It's just for the sake of reusability. Keep your view model in screen level composable and don't pass them down to other composable functions. Great. So today, what are we going to be doing today is we're going to be solving the state in Compose Code app that has two parts. It's a wellness app that has a counter of glasses of water in which you can add you can keep track of the glasses that you have throughout your day. And then it has a list of wellness tasks that you can check to mark them as completed, or click the X to dismiss them and clear them from the list. The final code is in GitHub. Now I'm going to put the link of the code lab itself, but you're going to be able to check the code after that it's done. And great. So I just want to say that we're able to help. All the developers are going to be around here, so you just raise your hand. We can come over. You can discuss other things related with state in Compose and architecture. So we're going to be here for that. And then it's code lab o'clock. So get your laptops ready. Internet connection is in your badge, the Wi-Fi Android latest stable. Or if you're feeling dangerous, just like go jump into Dolphin, whatever is your preference. It would be great if you have basic Compose experience and experience with Kotlin. And that is it. Thank you so much for listening, and we're here to help.